Welcome to Module 3. The 7 Steps of Cleaning and Sanitation. Let's start with a question. When two different people clean the same piece of equipment on 2 different days, how do we know they've both done it properly? The answer is that we follow a system. The 7 Steps of Cleaning and Sanitation is that system. It's the industry's gold standard for turning a dirty, contaminated surface into one that's safe for food production. And what makes it powerful isn't just the steps themselves, it's doing them in the right order, every single time, for the right reasons. That's what this module is all about. Before we walk through each step, it helps to see the big picture. The 7 steps are really 2 phases working together. The first 4 steps are the cleaning phase. Their job is to remove every trace of visible dirt and soil from the surface. The last 3 steps are the sanitizing phase. Their job is to kill the invisible pathogens that cleaning alone can't deal with. Think of it like this: cleaning clears the battlefield, and sanitizing wins the fight. Both phases are essential, and one cannot rescue the other if it's skipped or rushed. We need to get 3 words straight, because we'll be using them throughout this module. Cleaning means physically removing soil, dirt, food residue, grease. Sanitizing means reducing the number of microorganisms on a surface to a safe level. A sanitizer must kill 99.99% of test bacteria. Disinfecting goes even further, killing 99.999%. Disinfection is what we use on floors and drains, and in the highest risk areas. Your standard operating procedure, your SOP, will tell you which chemical to use and where. The process for applying them is the same, it's step 5 either way. The first step is called the pre-clean, and it's a dry process. No water, no chemicals yet. We're using scrapers, squeegees, brushes, or a broom to physically remove the big visible material from the surface: food scraps, powder residue, solid debris. On the floor, we sweep or vacuum before we ever introduce water. Why start here? Because if we skip this and go straight to washing, the detergent gets used up fighting that top layer of heavy soil. It won't penetrate to the surface underneath. We also save water, we save chemical, and we keep the drains from blocking. It's a simple step, but skipping it makes every step that follows harder and less effective. Now we bring in the detergent. The main wash combines 3 types of energy to break down and lift soil off the surface. There's chemical energy from the detergent itself, which is designed to dissolve grease and loosen organic material. There's physical energy from our scrubbing, and we'll come back to just how important that is. And there's thermal energy, meaning the temperature of the water. Hot water generally makes detergents more effective, but always check the product instructions, because some chemicals actually work best in cold water. The right detergent also matters. A degreaser handles oils and fats. An acid cleaner tackles mineral deposits and scale. Your SOP will tell you which one to use. Let's talk about the physical scrubbing part of the main wash, because it deserves its own moment. We know from Module 2 that bacteria can form biofilms, that protective slimy layer that makes them incredibly resistant to chemicals alone. The only thing that breaks a biofilm is physical force. Scrubbing with a brush or a scrub pad is what physically destroys that fortress. The chemical can then get to work on what's left. No amount of detergent, however strong, will lift a biofilm without the scrubbing that breaks it up first. So when we talk about the main wash, we're not talking about a light wipe. We mean proper, deliberate, physical effort, especially on corners, edges, and any surfaces that are hard to reach. Once the main wash is done, the soil is loosened and suspended in the cleaning solution, but it's still there. The rinse step is what physically removes it. We use clean potable water and we rinse from the top down, so we're not washing dirty water onto a surface we've already cleaned. But there's a second reason the rinse step is critical. If we leave detergent residue on the surface, it will interfere with the sanitizer in step 5. Detergent and sanitizer can react with each other. The detergent can actually neutralize the sanitizer, making it completely ineffective. So rinsing isn't just about removing dirt, it's about preparing the surface for what comes next. Before we move into the sanitizing phase, we stop and inspect. This is our quality check. We look carefully at the entire surface, in corners, around welds, along edges, anywhere that's hard to see. If the area is dark, we use a torch. The rule we're checking for here is one of the most important rules in food safety. You cannot disinfect a dirty surface. If there's still visible soil at this stage, the sanitizer won't be able to reach and kill the microorganisms underneath it. We have to go back and repeat the main wash and rinse until the surface is clean. It's far better to catch the problem now than to go through the whole 7 steps and end up with a surface that was never properly decontaminated. Let's pause here and really lock in that principle. A dirty surface cannot be disinfected. Soil physically blocks the sanitizer from making contact with the pathogens it needs to kill. This is why the 4 cleaning steps must be completed, and completed well, before we even think about applying our sanitizer. It's also why the inspection step isn't optional, and it's not just a formality. It's the gate between the 2 phases. If the cleaning phase hasn't worked, we don't move forward. We fix it. That discipline is what separates a professional cleaning technician from someone just going through the motions. The surface is clean. Now we move into step 5, sanitizing or disinfecting. We apply the correct chemical at the correct concentration to the entire surface, making sure every part of it is covered and visibly wet. Your SOP will specify which product to use, what concentration it should be mixed at, and how to apply it. Getting the concentration right is critical. Too weak, and the chemical won't kill the pathogens. Too strong, and we've created a chemical hazard, and we may also be damaging the surfaces or equipment we're cleaning. This is why we always mix according to the manufacturer's instructions, and why some facilities use automatic dispensing systems to take the guesswork out of it entirely. Here's the part that many people get wrong, and it's arguably the most important part of the sanitizing step. Every disinfectant has a dwell time, the length of time the surface must stay visibly wet with that chemical for it to be effective. This isn't a suggestion on the label. It's a scientifically determined contact period. Let's say your disinfectant has a 10-minute dwell time. If the surface dries after 5 minutes, you have not disinfected that surface. The chemical simply hasn't had enough time to do its job. If it dries too quickly, we reapply the disinfectant and start the timer again. The dwell time is law. No shortcut here. A few things can affect whether a surface stays wet for the full dwell time. The environment plays a role. A well-ventilated area or a warm room will cause surfaces to dry faster. The size and texture of the surface matters too. If you're disinfecting a large, porous or uneven surface, you may need to apply more product to ensure full coverage and enough moisture to last the contact period. Know your environment. If surfaces in a particular area consistently dry too fast, that's worth raising with your supervisor. There may be a more suitable product or a procedure adjustment that can help. The goal is always to meet the dwell time, every time. Step 6 is the post-rinse, and this one requires you to know your specific product. Not all sanitizers need to be rinsed off. Some are what we call no-rinse sanitizers, They're formulated to be left on food contact surfaces and are safe at the concentration they're applied at. But most disinfectants applied to food contact surfaces do need to be rinsed off with clean, potable water to make sure no chemical residue ends up in the food. For non-food contact surfaces like floors, a post-rinse is usually not required. The rule is straightforward: check your SOP and know your product. Skipping the rinse when it's required is a food safety failure. It's a chemical hazard you've created yourself. The final step is drying, and it's easy to underestimate just how important it is. Cast your mind back to the FATM conditions for bacterial growth from Module 2. One of those letters is M for moisture. Bacteria cannot grow without water. By ensuring the surface is completely dry after sanitation, we're removing the last ingredient bacteria need to survive and multiply. Any few microorganisms that happen to survive the sanitation step can't go anywhere without moisture. We can allow the surface to air dry, or use a clean single-use cloth or a clean squeegee. The key word is clean. We're not introducing new contamination at the very last step. There's a second reason drying matters. A pool of standing water on a surface isn't just a growth environment for bacteria that are already there. It can also pick up new bacteria from the air and allow them to multiply. A dry surface is a stable surface. It holds its clean state far better than a wet one. So drying isn't a finishing touch, it's a genuine food safety control step. When a surface has gone through all 7 steps correctly and is sitting dry and ready for production, that's what success looks like. That's a surface we can be confident in. Let's bring all 7 steps together. The slide ahead shows the full sequence. We start with the pre-clean, removing bulk debris dry. Then the main wash, detergent and scrubbing. Then the rinse, clean water, top to bottom. Then inspection, the gate between phases. Then we sanitize or disinfect, correct chemical, correct concentration, full dwell time. Then the post-rinse if our product and SOP require it. And finally, we dry. Each step prepares the surface for the next one. Each step has a reason. The order is not flexible. This is the sequence that the science demands, and it's the sequence that keeps people safe. It's worth being direct about what happens when we get the order wrong. If we sanitize before we've cleaned properly, the soil blocks the chemical and the pathogens survive. If we rinse with water before we've finished scrubbing, we're washing away our detergent before it's done its job. If we skip the dry step, we're handing bacteria exactly what they need to grow back. Shortcuts don't just produce mediocre results. They produce the illusion of a clean surface while the hazard remains. The 7 steps only work when they're followed in full, in order, with intention. That's not overcaution. That's just how the science works. A quick but important point about how all of this connects to your daily work. Every facility has its own standard operating procedures, SOPs, for each cleaning task. These tell you which chemical to use, and at what concentration, what temperature the water should be, what dwell time to apply, whether a post-rinse is needed, and how often the task must be done. The 7 steps are the framework. Your SOP is the detail specific to your facility and your equipment. When in doubt, go to your SOP. If something in the SOP seems unclear, or the procedure doesn't seem to be working, raise it with your supervisor. The SOP is a living document, not a fixed rule. It can and should be improved. One more thing before we wrap up, and it's easy to overlook. Your tools are part of the process. A brush with loose or missing bristles isn't just ineffective, the bristles themselves become a physical hazard. A cracked bucket can harbor bacteria in its crevices. A torn cloth can leave fibers on the surface. Before you start any cleaning task, take a moment to inspect your tools. Check brushes for loose bristles. Check buckets and handles for cracks. Check cloths for wear. If something's not in good condition, replace it. Worn-out tools undermine the whole process, no matter how carefully you follow the 7 steps. There's a view sometimes that cleaning is simple work. This module should have changed that view. What we've just covered is a systematic scientific process built on chemistry, microbiology, and professional discipline. When you understand why the main wash needs scrubbing, why dwell time cannot be shortened, and why a dry surface is a safe surface, you're not just doing a job. You're applying knowledge. You're making decisions. You're protecting people. That's the mindset of a food safety guardian, and it's the mindset this course has been building in you from the very first module. So that's the core skill of our profession: 7 steps, 2 phases, and a clear scientific purpose behind every one of them. In the next module, we move into territory that's just as important. How do we know that our cleaning actually worked? We'll look at monitoring, verification, and record keeping, the tools and habits that turn good cleaning into documented, defensible food safety practice. If this module was about doing the job right, the next module is about proving it.